All right, this video is covering the first section of the review chapter, or what we refer to in this book as section R1. And it's dealing with sets. And so overall, the set notation that you get here, in the grand scheme of things, is not a huge part of what we learn this year. But you will see these kinds of sets and this notation for set notation in future math classes. For example, I use some of these symbols that you see here when we talk about probabilities in AP statistics. So not a huge part of this year's topics, but something that you will see again in other math classes. All right, so set notation. So we use these braces, these are like the little squiggly parentheses, to denote all of the elements that are going to be in a set. All right, so we use capital letters to indicate set. So we say like a set, M. M is a set, and that set contains 4 elements. It contains 1, 2, 3, and 4, those integers. So we might use something like 3, and then this symbol, which looks kind of like a curvy capital E, and that is that symbol means element. So 3 is an element of set M. All right, and so that's kind of how we say it. 3 is an element of set M. And that is a true statement because 3, sure enough, is one of the elements that's in set M. 8, some examples here. 8 is an element of the set. 5 is an element. Is not an element, so it's this squiggly with a slash through it, like you see, like equal to and then not equal to, right? We put a little slash through, it means it's not equal to. So the slash here just means 5 is not an element of this set. So this set contains -2, -4, -6. Clearly 5 is not an element. All right, this is just a really fancy way of sort of writing your answer. So your answer is X such that X, so we're talking about a set because it's in parentheses, it's in these braces, right? So we're describing the set in here. So the set is X such that X is a natural number where X is less than 4. So natural numbers, if you remember, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, and we're going to talk about the different sets of numbers in the next section. But that is essentially, all of that is saying a set that contains 1, 2, and 3. So the set is any X value such that, that's what that vertical line means, such that X is a natural number where X is less than 4, is a big long way of saying 1, 2, or 3. Okay. All right. The null set is essentially the empty set. Sometimes it's referred to as no solutions if you are actually looking for, like, what is the set of all solutions. If there were no solutions, you'd say, like, oh, the solution set is the null set or the empty set. So we use very different notation. We sometimes, like in a computer science class, to differentiate between O and 0, we'll put a slash through zeros. But don't do that in math class because that symbol doesn't mean 0 anymore. It means the null set. Right? It's the symbol for a null set. And we don't want to be using, when you write a 0, just write 0. Don't put a slash through it. I know I've come across students whose previous teachers always say, put a slash through it so you don't differentiate it between O and 0. And that really is only important. There's ambiguity in computer programming because if you type an O, the letter O, where you're supposed to type a 0, you could get some errors and things like that. So in computer science class or a coding class, you would use this for 0 and this for the letter O. But here in math class, we don't do that. 0 is just written like that. Okay, so make sure you have a 0 is no slashes through. The null set is a 0 with a slash through it. Now that's the same thing as the empty set. Okay, so those are essentially the same thing. What you should not do is put a null set inside the empty set. They're the same thing, so putting one inside the other doesn't really make sense. So don't combine them. You use the null set or you use the empty set. If the set is empty, essentially there are no elements in the set, then you can refer to it as either way. All right. If the set n, so capital letters to denote sets. So if n is equal to 1, 2, 3, 4, 5, dot, 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 you can kind of see the pattern there, so we can assume it continues, and it will continue infinitely. It will continue on, so there is no end, like there is up here, like this one ends at 10. Here there is no n, and we say dot, 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 so this is referred to as an infinite set, okay? All right, subsets now. Subset is a set that is wholly contained inside another set. So set M, if the set M has elements 1, 2, 3, and 4, and set N is any x values such that x is a natural number, then that means set M is a subset. That's what this symbol means. It's a sideways U with a line underneath it. So that means set M is a subset of set N. All right, so N being all natural numbers. Clearly 1, 2, 3, and 4 are natural numbers, but they're not all the natural numbers, so M is a subset of N. All right, some special cases. N is a subset of N, so every set is going to be a subset of itself. The null set, or the empty set, is a subset of any other set. All right, so the null set is a subset of any other set, including itself, I guess, right? You could say the null set is a subset of the null set. These are all kind of little special technicality cases. If A is a subset of B, and B is a subset of A, then what do you think? That means set A must equal set B if they're subsets of each other. Okay. The universal set, U, when discussing a particular situation or problem, such as rolling a standard die, so a 6-sided die. The universal set, whether we express it or it's implied, contains all the elements. So in our discussion, in this case, the universal set would be 1, 2, 3, 4, 5, 6 for a standard 6-sided die. Okay, so it's sort of the universal set, just is general, depending on the situation we're talking about, it's all possible values or elements that could be in the set. All right, Venn diagrams are useful when describing sets. So universal set, that's all the possible values. And then B is a subset of the universal set. And then A is wholly contained within B, so A is a subset of B. A would also be a subset of the universal set as well. All right, complements of sets. So in this case, you are either in B or you're in B prime or you're in B. So you think of these as complements, one or the other. So the complement of B, sometimes called B prime, so we write that as a little apostrophe next to the B. So you're either out here in B, or you're in here, out here with B prime, or in here with B. So we think of these as complements, one or the other. I guess maybe when we're looking at this case, B prime, so B is not a subset of B prime. B prime is the complement of B. So if we said, rolls of a dice that are even, so that would be 2, 4, and 6, and then the complement of the even would be the non-evens, or 1, 3, and 5, if we're talking about dice. So 1, 3, and 5 would be the complement of 2, 4, and 6. Those are complement sets. All right, so we call it B prime. We put, again, that's apostrophe. We call it prime. Is the set of all elements in the universal set that do not belong to B. All right. For example, if set D is a set of all even outcomes when rolling a standard die, then D prime would be all the odds, the non-evens. That's kind of the example that we just did. All right, intersections versus unions. So an intersection is thought of as an and then the union is thought of as an or. All right, so let's look at an example. If we're given A, the set A contains the elements 1, 3, 5, 7, and 9. And B, set B, contains the elements 4, 5, 6, 7, 8, 9. Then think about what is the intersection of A and B. So what's in A and also in B? That's what that symbol means. The symbol means and or intersection. This symbol, it's good to remember this one. It looks like a U. It represents the union or the or. Okay, so what is both in A and also in B? So what's in both? So 1 is not in both. 3 is not in both. 5 is in both. So let's do this. Let's do it as a set notation. So 5 would be in here. 7 is in both. 8 is not, but 9 is. So the intersection of these two sets A and B is the set 5, 7, and 9. Now the union, so union means or, so it means it's in one or the other or possibly both. So we simply, anything that lists in either one has got to be listed. So that would be 1, 3, 4, 5, 5's in both, but that's fine, right? It can be both. 6, 7, 8, and again, 9's in both, doesn't matter, we're going to include it. If it's or, means it's in one, or it's in the other, or it could be in both. Now we can represent this idea of and or intersection and union visually with a Venn diagram. So which of these four, so we've got two Venn diagrams and we've also got written out in set notation. So think about which of these four represents the A intersection B and which could be used to represent A union B. So that's how we say it. We say A intersection B, that means the intersection of A and B. A union B, that means the union of set A and B. All right, so this one is the of course I wrote it as a union, represents the intersection of them. So it's the thing that's in A, and so everything in A is inside this circle. Everything in B is in this circle. This shaded region in between is the stuff that's in both A and B. So it's the overlap. And then this one, the shaded region, represents anything that's in A, anything that's in B, anything also that's in both. All right, so this would be A union B. All right, it's the or. Remember, this is the and or intersection. This is the or. All right, the set such that x, right, x value in the sets, the elements, it's the set such that x is an element of A or x is an element of B. So the or kind of gives it away. This is the A union B, and the and, that's the A intersection B. Okay, so that's it for this. There is some homework. I think we have that on a separate sheet. Homework R1. Normally our homework will be out of our books, but this homework is on an included worksheet.